So for this capacitor circuit, we gotta find the charge on each capacitor. Now I know it looks like C2 and C3 are in parallel, but they're not quite. It's better to start with C1 and C3 being in series, and C3 and C4 being in series. This is all one big series, right? So I'm going to change this. I'm going to reduce this system and simplify it so that we've got one capacitor that has a capacitance C1, and I got another capacitor over here that is C134. Okay, and to find C134, those capacitors are in series, so that's 1 over 1 plus 1 over 3 plus 1 over 4. So C134 is 0.63 microfarads. Now, oh, I'm sorry, this is C2, isn't it? My bad. So C2 and C134, now those two are in parallel, right? The voltage on this side and the voltage on this side is the same. So I can write this finally as a single capacitor, C total, where C total, when you have capacitors in parallel, you add them up, right? So C2 plus C134 is 2.63 microfarads. And I know the total voltage is 24 volts. And so I can calculate Q total. That's C total delta V total, which is 63 microcoulombs. I don't really need that, but it's good to have it as a check for later. What I need now is I need the voltage drop across each one of these capacitors, right? So the voltage drop across capacitor Q2, delta V2, that's going to equal delta V total. That's going to be 24 volts. And likewise, delta V across capacitor 134 is also going to be 24 volts. Right, you see why that is? Because up here, if this is at 24 voltage and this is at 0, then everywhere where there's an X, that potential is 24 volts. Okay? And on this side, everywhere there's an O, that potential is 0 volts. Okay, so the potential difference across both of these capacitors is 24 and 24. So for capacitor 2, I can say that Q2 is C2 delta V2. So that works out to be 48 microcoulombs. So I'm done with Q2. And now I got to take that capacitor 134 and figure out what's going on. Well, the charge on capacitor 134 is equal to C134 times delta V134. And C134 I got from up here, yeah? So 0.63 microfarads times 24 is, I guess, 15 microcoulombs. Right, I guess I left out a 10 to the minus 6 here. Okay, now, just as a check here, I know that since C2 and C134 are in parallel, that these two charges here need to add up to the total charge, right? For parallel capacitors, we have the Q total is equal to Q2 plus Q134. So I'm glad to see that checks out. At any rate, for Q134, if the charge is 15 microcoulombs on this capacitor here, then that means that the charge on each of these three capacitors is the same, right? For capacitors that are in series, Q total, or Q134, sorry, is equal to Q1, is equal to Q3, is equal to Q4, and that's 15 microcoulombs. So I'm done with those as well.